Okay. So can you hear me correctly here? Okay, because I'm letting down the microphone. I'm getting installed behind the laptop and the computer, so I won't be here for this presentation. I will be behind the laptop because it's a workshop. So a workshop is also to beyond the slides that are necessary to maybe introduce things. There is also the need for experimentations or at least demonstrations. What I was thinking about was much more to propose you through the coming 20 minutes through a journey by visiting our interface. Just to make it clear, this interface is open, available on a server, and I have highlighted the key points that I wish to investigate with you within the coming 20 minutes. The first one is BERT and question answering in physical effects. We have heard already a little about it before. I would like to investigate semantic similarity between generic specific problem and generic problem equivalence, or evaluating parameters equivalence. You know those two parameters you are trying to investigate for having access to Altshuler matrix. Some machine learning and neural network trained to recognize inventive principles in the text. Some deep learning and GAN extracted from Guillaume's work extract contradiction from patent. And some large language model, GPT 3.5, to generate responses from very large database of scientific articles based on Nicolas' work. And something issued from OpenAI API is building hidden prompt, but in some generic way, in such a way to have an intelligent assistant when you are constructing a problem formulation and contradiction identifications. So this is a list of the items I would like to go through. Now we are entering into the system. Okay, so I'm switching off the PowerPoint and I am moving to Firefox. Okay, so trying to get the website. Okay, so we are now in front of our platform. So the keyword to access to this platform is rather easy to, let me make it bigger. Okay. And you can obviously sign in and sign up on this platform. So I put my real time, okay? Oh, that's, yes. I have the numbers. Okay, that's me. Okay. So here's the platform. The platform is proposing aside some basic news on a landing page. You could register as a user. As you can see, we already have over 800 users, 29 organizations. If you click on organization, you have an overview of who is using it yet. Okay, so there are quite a few organizations, and there are two types of it's not with any cost. Okay, just to make it sure, it's not something that you can pay. It's for two types of users. It's for either our funding industrial partners or for any trees professor or trees teacher. Whoever is teaching trees, consider that he can have access for his teaching purpose to the platform for free. So that's the deal. It's not open source, to anticipate the question of Isham. Okay. So there is a 20, you can create a session. If you are a trees professor, you might be glad to create a session, and having the capacity to ask to your student to be grouped into projects. So every time we create a project, we have a group of students that make their own proposal of project. Here you see an hydroelectric turbine, soap for travel, soap box for travel, flower pot, headset, or whatever the topic is. This is how to create session. Session means multiple projects for a complete class of students. Each student can constitute a team. So obviously the team is tightly linked with the subject within a session. And each team can create, or individual, can create as many projects as you want. So you can see that there is already 770 projects already on the platform. There is a small game that I have proposed to the students and to our colleagues from industry, is to contribute to the database of examples. So the trick is to gain trees coins. So by loading an example in the platform, you gain trees coins. So you can see that some of them have 1 or 2 trees coins, and I'm waiting until somebody beats me, because I think I have something like 47 trees coins. It's rather easy, and it's human-made example. It's not unhuman-made extraction, not automated one. Because we hope one of these days it could constitute a corpus of good solutions. So here is the project, and let's start the journey into the software. Dealing with physical effects could be an interesting first trial. Is how to move a solid, how to measure temperature. Okay. So let's start with that. You have a similarity threshold. And it's plugged directly to Wikipedia, and it's BERT. Okay. So you could obviously access to the page, because if you want to have access to the Wikipedia page, it's obviously linked. And since the page are public and I only face with the first image, paragraph, and title of the Wikipedia page, I'm just popularizing a Wikipedia article. So you can change the threshold if you're unsatisfied and be more restrictive and put a threshold to 80, 85 and see. But they are ranked by the level of accuracy, so of the threshold. So you can browse, and this is a very simple function. browsing, physical effect. I remember the old physical box into Invention Machine where you had the tables at the bottom of Altschuler book, and it was limited to 300 or something. Now, as long as Wikipedia is growing, this database is also growing. And you could ask not only the list of pointers to effect questions, which were limited, to unlimited question as long as you formulate it in natural language. So, and it's a very simple AI function with a constantly growing database, somehow trustful, because the system of validation of Wikipedia can bring you an interesting way of practicing. Okay, so we continue in a journey, and let's start with project. Obviously we're going to start a project. Let's call it July 6 test, and I could associate whoever I want to the project as long as it's in a list and in the database of user. I can add details, but this is nothing special here. Once you have created your project, I leave the task manager because this is a Gantt diagram and it's not new. So extract data can start to be a first interesting aspect of dealing with artificial intelligence before starting any project. So types of data, trustful data, patent. We have seen it with Davide, and most probably all of you are familiar with using patent as a source of knowledge. We have news and article, either by entering keywords or URL if you have directly browsed internet, and if you have the URL link of the news you would like to integrate into your knowledge base, or research papers. So let's play a little with patent, and to test it very openly, I'm going to take the Davide subject. So you say popcorn machine. Okay. Popcorn machine, and I get result because and limited result, not so much quantity, because I limited it to the title and the abstract. While even we have the full text and images of the patent, because unfortunately most of you know that GAN and deep learning activities are very demanding in terms of power and in terms of availability of data. So I hardly imagine to access to a distant database of patent with an API, because sooner or later you will be restricted by the quantity or the processing of large quantities of million patents for free to be uploaded in your own server. So unless you have a lot of money to pay them. So here I am simply, and we are at the school simply using USPTO, because USPTO is the only open downloadable zip file weekly database. So we uploaded 11 million patents USPTO on our own server to benefit from the full text and really perform research and deep learning activities, because 11 million starts to be a good sample out of 200,000 million. So this is popcorn machine. I'm not going to read. I'm simply going to trust the fact that I have popcorn machine papers. I haven't looked. Of course, you can carefully look on the data you are putting inside the machine, but let's say I'm going to select the first 100 ones. Since I have 31, it means that all my first layer of popcorn machine patents are selected. And I am going to ask the machine to extract content of this 31 patents. You will note that the processing of this 31 patent is not so fast. It's deep learning activity on large corpus, and the API which we have customized and entirely built based on the PhD of Guillaume is homemade. I mean, we did not took, of course, you have a GAN behind while it is calculating. Guillaume can, I see Guillaume smiling because Guillaume says, I hope it's going to work. I hope we are live here. Okay, good. So how many? 3 minutes? 2 minutes? Okay, 31 patents. Let's investigate. I didn't knew the topic before. Okay, we're just explaining. It is also known that it is difficult for a user to evenly season their popcorn with the current seasoning method provided. Okay, why not? However, the site, so there is a contradiction here. I forgot to explain you a little bit about our way of modeling data and knowledge, but the red spots you have here are problems, and the blue nodes you have here are partial solutions. And the link between problems and partial solutions are, in fact, have a special meaning that you can have at the prompt, or the pop-up prompt here. When a partial solution is impossible to find in a patent as a sentence in natural language, you have the possibility to access to it and say, is there a parameter behind? Not maybe a sentence, but maybe a parameter, which obviously will be an action parameter, while you could attach to each problem evaluating parameters. So here we have a bunch of proposals automatically extracted from patent, from the whole corpus of patent, in order to have access to the knowledge content of unstructured text within the patent. I could check one by one. Here you can see 152 elements of the ontology that have been extracted, be it problems. If you have a smaller quantity, you could investigate, and more time, you could investigate them one by one. Here, since we don't have so much time, I'll take them all. Okay. And I am asking yes, and I import all this knowledge into my workbench. So now I have a graph constituted by 152 elements of knowledge extracted by 31 patents from popcorn machine case study. We have a small tool here, which is a scan grapher. Made some like doubles here, similar nodes or nodes that would mean the same thing or have close meanings, possible to cluster, diminish the noise or the quantity of data. As you could see in the coming steps of the process, you have the parameters. The parameters are automatically extracted from the sentence, so they are not trees customized or trees designed, but you could see that each problem formulated integrates the parameters, and the parameters within the sentence have been all extracted and constitute a corpus of parameters useful to build contradictions, in fact. So how to build contradiction from that? Well, if if it has been respected, the model of construction of a problem graph, now it's only computerized, so we believe it's somehow useful, somehow correct, unless parameters or sentences are wrong. So if you have time, you could polish a little bit by removing what you think is not good, but by rapidly looking at the problems, they look like problems. By rapidly looking at parameters, they look like correct parameters. So I'm not going to correct everything since it seems correct for the demonstration. So the step build contradiction is the next step in which we do have a automated function. You know all the structure of a contradiction. So I am going to propose an autofill from graph. So I'm going to propose to the software to automatically build the contradictions. So some contradictions you can see are incomplete, but you can see that some contradictions are proposed and complete because you have several parameters in opposition. Of course, the value and opposite value to constitute a physical contradiction might not be all formulated. It's out of our scope yet, but you could see that many potentially interesting contradictions have been extracted from that corpus. So what to do with this contradiction? All three experts know that now dealing with those contradictions is selecting which is the most suitable one for solving. Statistically, we have ranked all contradictions by their frequency in a y-axis here. So you could select one by one each contradiction and saying, oh, this contradiction is interesting to me, and because statistically, these parameters are the most frequent one found in the overall population of parameters. And then you could try to investigate deeper if this contradiction speaks to you, or if this contradiction is false and if you need to correct it. But at least it gives you an automated extraction with several minutes work from the beginning. Without the true need of an expertise behind. Do you see this cloud? And this cloud seems, oh, it seems like inventive principles. Yeah, it's inventive principles because the software behind, while I was speaking, is drawing parallels between each parameters, one by one, contradiction by contradictions. Let me check how many contradictions you have. We have 42 contradictions in that population, okay? So one by one, the software has estimated the parallel between the list of parameters I just extracted in contradiction and the list of the 39 engineering parameters by Altshuler, and has already investigated the statistical content of the matrix to highlight the series of inventive principles in the overall population that are the most statistically potentially useful for solving the dominant series of contradictions. So it's a statistical representation based on a semantic similarity work between my series of engineering parameters and the generic parameters of the matrix. Another interesting feature that could be statistically represented is the heat map. So the overall based of the layout of the contradiction based on contradiction matrix. And you could see that through this population, you have competitors. So if I want to highlight which competitor is dealing with which contradiction, I could browse them. Oh, this one seems very active in many of the Altshuler matrix. So Sterling Company is dealing with solution to that contradiction with its patent. So that's interesting because you could investigate the population of the landscape of the owner of the patent, remember, 31, who is active in which location of the Altshuler matrix to propose a solution to a given contradictions with his patent. That's the way you read this graph. And the density of blue is the statistical quantity of patents that are grouped using a topic modeling in which array of the matrix when the terms are close to each other, or when they can constitute a group. So by going to the darkest contradiction, you could also go to the most statistically representative contradiction of the overall population. You have all of them, and we see that, for instance, in this cell, we have two patterns or two contradictions found in the same patent. You have the trace of this patent, and you have the trace of this contradiction. So it's interesting because we could have access to interesting analysis almost semi-automatically in order to solve potentially contradictions. If I am interested to go deeper now with this contradiction and try to solve them, you have several ways. Let's say I'm taking the most statistically representative, and I am going to take one contradictions. Okay, these are much more not really engineering ones, but okay, let's take this one. If you select the contradictions, it means that you are ready to engage it into a solving process, and then you go to the step where you are assisted to generate ideas, and then it helps you to directly work with a single contradiction. Of course, you could complete this contradiction if you are unsatisfied with its content, but you could also look at the automated location in the matrix. Automated means may be wrong, may be right, but may be wrong. It's based on the semantic similarity. And either you correct it by changing the content of the association to the matrix, either you accept it and then you go deeper. So the statistical representation of the inventive principle obviously are based on the Altshuler matrix, and the fact to select one contradiction makes visible where this inventive principle is located within the overall matrix. And if, for instance, I select principle number 27, I go back to the app, I could now have a selection of online examples that are using inventive principle number 27 to propose an innovation over the web. So this is the Treescoin owner who have this database. So we exactly know that behind there is not yet an automated task or a fully automated task. We have here a human-built database. The database is about 3,000 examples, so it's not unlimited, but it's a good input in order to now trigger your creativity when searching for ideas by interpreting inventive principle number 27. Of course, if you are interested in saying, I use this one inspires me, I could select the inventive principle, go to the next step, and interpret by adding a solution. So I say, if I create a solution, if I put foldable popcorn container. Okay, I submit. The interest of having such a solution means that right after, you will have a possibility to rank your ideas with all of your evaluating parameter extracted from the corpus database. So here I have not eliminated doubles, and I have not eliminated rubbish. So I have the total population of evaluation parameters grabbed from the population of patents. If I want to have a smaller quantity, I can do it, and I can assess the impact of my idea with the list of parameters, where if I'm doing very rapidly in order to have a statistical result. Okay, stop here. You go next, and then you have the link. Your ideas is solving several problems and one contradictions, and it is inspired by an example that you have just selected. You export your report, and the students are very happy when they can open their Word file and when they have a complete report available for them in their report. Okay. Well, it's a Word file. Okay. So you could have access to the whole study you just made as a Word file. Okay, so that's a first example, a first test of the platform. The idea is to teach using it trees, but also if you spend more time on it, we have people here who spent many weeks, not to say months, on the platform to work on real industrial examples. Here we are playing with the platform and browsing it rapidly, but obviously you could do much more serious projects if you spend longer time and having interesting results. Another thing maybe I could demonstrate is the automatic association with an article you could get from the web. So let's say I am searching for information about whatever topic. Okay, let's say popcorn machine problems. I don't know what will come out from that. Let's say news. Okay. Okay, let's say I'm taking one example. I think this article is interesting, so I copy the hyperlink. I move back to ideas, and then I'm going to the database of engineering examples. Then you see how you can become bronze, silver, or gold contributor. You import the URL here. If it is not forbidden, you scrap the content. You obtain a title, a text, and sometimes an image. Yes, and you have automated proposal of inventive principle that are associated with the content. So we trained the model using the database of engineering example, humanly built, to now automate the process of retrieval of the inventive principle tagging. My advice is to verify, because it is taking into account the whole text you have here. And if you have rubbish content in that portion of the text, it might fool the result. So my advice if you want to use this is to limit to the portion of text where you feel the inventive principle is observable. And if you found it, remove the rest in order to remove rubbish and gain accuracy in the identification of the problem. If you import this example, you have your name, you gain a Tris coin, and it's in the database. Okay, I am going to save time for the remaining part of the day, but I would like to display, of course, other things are going on at INSA, but at our school. My advice would be for those of you interested in looking at our recent advances, you go to Google Scholar, you type my name, and you read our articles. They are available, and you could cite them if you are interested to publish also, since we are publishing all activities in link with our PhD students. Thank you for your attention. And questions and comments from either the audience here or distantly. Okay, let's for the first time start with the distant questions. Any AI-based trees tool being developed and worth to follow? Well, let's say that in the package you have seen here, in this package you have tools that are totally taken off the shelf, API available over the web, like BERT or things like that. They have not been transformed, trained, or finely tuned. Several examples here, like going to search for a physical effect. You have things that have been partly trained by using partial elements existing and built by the techniques we know, and some algorithm found when you use TensorFlow or other bank of algorithms. And for those of it, you have also several features you have seen here. And you have totally built API based on PhD work, like the extractor I show with the portfolio of patent. So to answer the question, we start to see, and I believe it's the same with Trix platform that we have just seen. We have both available AI trees-based or trees. I'm not sure if I understand well the question, but AI-based trees tools available based on the current work. Now, the remaining part of your question, Jeff Lim, is it worthwhile to follow? It's not me to say. It's up to you. I mean, if you want to do like we did with most of the existing tools, my suggestion, test them all. Or if you are a professor, put your student on each of them and build some tests in order to make your own opinion on it. Right now, it's a new birth discipline that we are trying to coordinate here. So I can't say at that moment there is an acknowledged publicly available work and largely diffused that I would advise. You have attempt, you have more or less successfully validated scientifically work, but nothing that sticks out as being the only thing to follow. Any other comments or questions?
Thank you, Denis, very much. Yeah, beyond the interesting research side, I'm also curious to see about the development. I mean, developing the platform by itself, it's a work, hard work actually. And do you use the internal resources, or how do you deal with the development?
Yeah, so this is a very interesting question because those who have built their own platform, configure their own server, or even if you buy external services, it's either man consuming or effort consuming, either money consuming if you buy, but it's the same in fact. So To perform deep learning activities, I could ask, I'm looking at Guillaume and Elias, but especially Guillaume because he had configured our GPU server, but it's the necessity is to have GPU. I mean, you could hardly calculate on CPU such thing, or at least operate deep learning algorithm. So you do need GPU and you do need to have a server. Your server should be sufficiently free to be accessible to your needs, not something that is blocked. At the university, we do have GPU, but it's only for PhD calculation. It's not for freely being open to the world on the server. So we had to build our own and bypass the firewalls in order to make them available also to our industrial partners, for instance. So it's a hard work. It's a very long, thanks to Guillaume, he configured everything in a server with a small quantity of money because when you start a PhD, you never know where you're going. So you cannot start with €100,000 investment. So you start small, and of course it takes 3 minutes, but it's sufficient to make your scientific proof, and it has been also useful for many other PhD after him, 2 or 3, to continue using this server GPU for implementing the calculations, the deep learning calculations, or whatever other AI techniques put into practice into that server. The development side is also costly. If you ask a developer to develop that platform, you know that this developer won't do it for free, for sure. And if you want a good developer, if you want a developer that is not bringing you a work with full of bugs and comprehensive code that you could implement, you could start by building a list of requirements using trainee students in computer science, because you need a translator. If you are not computer scientist yourself, you need a translator between you and the developer. So if you develop sufficiently long-term and trustful relationship with a developer, which is the same after year, then it starts to understand your need as a researcher, and he could transform it into which code I will use to build that function into the platform. And slowly, little by little, we found after several iterations, we found this developer, and now he's working for us for the past 6 years now, and he's been building totally the platform. And now we can't do without him at a cost-effective rate. So we continue. So fidelize your developer, make a relation of trust with him in order to save this developer throughout the years, because it won't take you 6 months to do such work. So, and once you have this developer and a platform, a server, both a server to implement your access to the code, and a server to make the calculation with GPU, which might not be the same server. Depends on your architecture. But you do need the front and the backend in a place. We have a server and Dockers in the server in order to uniformize the way our PhD and our student and our trainee are working. And after, when you think research work is mature enough to be transformed into a professional, into an online version, not a demo or a trial, then you give it to a real developer who spend hours. It will cost you money, but you will have your online platform. And then you could use this platform for building the next step, and building the next step, building relationship with your student, with other university, with companies. But without that, without such a platform, it's difficult because you are only displaying slides with your people. And if you have your things on your own laptop, it means that you always need to be here to make the demonstration of what you do. Here, you type ir.eu and you are on our platform and you do it on your own. So this is the hard work. It took us almost a decade, but now it's done. Now we can think to how to dig it further and how to do something more in order to propose new functions. Any other comments or questions? Okay. So thank you very much for all of your attentions and questions. I'm just grouping rapidly. Thank you. I asked a question before your demo. You have just demonstrated that. Okay. Thank you very much. I think Jeff, I have answered your question, hopefully, within my previous answer. So we are now switching to the next presenter.